So this demonstration is about demonstrating ROS2 Nav2 stack running on a physical robot, so Lego robot running Raspberry Pi. I've got a few Docker containers in which I'm running ROS2 already set up. Just to speed up the demonstration, so this window here is it's an SSH shell onto the physical robot itself, running ROS2. We have the differential drive controller running, and it's broadcasting an image and also a LiDAR message, hopefully. I've got a couple of I'm decompressing here couple of image streams. So I've got a MacBook set up, which so I'm decompressing here the stream from my MacBook, and also here I'm decompressing the stream from the robot Thomas onto the desktop. And I've also just set up a joystick controller in this window on my desktop. So if we go here, and let's just start ROS2 to show you what's going on. Let's add those two images there. MacBook image, okay, and let's get the image from the robot itself, and that's now on my desktop as server Thomas image. Okay, let me make this a little bit bigger so I can now control this with my joystick from my desktop. Okay, so let's go through these demo step by step. Okay, so your robot should receive, these should be twist stamped messages, so let's check that they are twist stamped messages. I think I want another window for this, and I need a Docker container to execute that in. So I'm just going to start another Docker container. Okay. Right, let's have a look at what is on CMD vel. Okay, we've got twist stamped, one publisher, one subscriber. The publisher, of course, is the joystick on my desktop, and the subscriber will be the ROS2 control system, and it is twist stamped. So we get back to the instructions. Your robot, yep, that's looking promising, and as we saw before, it works. I'm just going to pause just for a second before going on to the next topic. Okay, for the next thing, we should be checking that we are publishing. Let's check our odometry. So first thing is check that we've got odometry messages on topic odom. Okay, so let's go to that. Let's try that again. Okay, that is looking good, and it is. Let me ask what is the type. Info/odom. Yeah, the messages are type odometry. Okay, we need a base link to odom transform. So make sure we have that. ROS2 topic echo/tf. Okay, and our transforms, we've got child frame base link in the frame odom. So that's looking good. Next thing is we need to check calibration. I think I'm going to demonstrate this broken first of all. I am going to break it. So I'm just stopping the controller, the differential drive controller. Okay, ROS2 mobile Thomas config controller. Let's break this. And so it should be 1.5 centimeters approximately. I'm going to make it 1 centimeter, which is wrong. I don't need to Qualcomm build it because it's sim-linked. I'm going to restart this. Let's wait for it to come up. Okey-dokes. Okay. So I'll use RViz to demonstrate this. So let's get our pictures back, and we'll need an axis to demonstrate this. I'm going to set the top down ortho and just zoom in there. So I'm pointing in the middle of the radiator. Let me just sort out my frames. So we want this to be our fixed frame to be ODOM, and our reference frame for the axis will be the robot itself, which is on base link. Okay, and I'm going to now, so we're facing the middle of the radiator. I'm going to do a 360-degree turn, and the red arrow is pointing in the positive X direction. If this is all calibrated correctly, by the time I've spun round and facing the radiator again, the red arrow should be back on the X axis. So let's rotate around slowly. And I'm going to stop when it's pointing in the middle of the radiator again. So that's a 360 physical degree turn, and if we're calibrated correctly, the red arrow should be pointing in this direction. It's not. This is hopeless. This is terrible. This will not work at all in Nav2. So let me fix that. I'll fix that. So let's go back here, and I think probably the easiest thing to do is I'll just go in here to mobile Thomas config. I'm just going to check it out again, and here's the controller. Let's go back and relaunch. Okay, let's go back to RViz. Let's get our pictures back up. Okay, we're going to try and spin it around again. So I'm spinning around physically to sort of face the radiator again. So it's probably something like that. It's not perfect, but I think it will probably do. It's acceptable, so it will be good enough for Nav2. It only needs to be approximate. The previous demo was just too bad to be usable, but I think this will work. Okay, I'll just pause this for a moment. Okay, let us now check that we've got our LiDAR set up correctly. Okay, so we need to be broadcasting messages on topic scan, and we need to ensure that it is correct, at least with respect to the base link frame. Personally, my on my robot, the LiDAR broadcasts on the base laser frame, and I've got a static transform that goes from base laser to base link to fix up. It's in a slightly, it's rotated by 90 degrees, so that static transform should make sure it's correct within base link. Let's check that. Okay, so I'll bring up my images again so we can see what we're doing, and I am going to let's get rid of that for the moment, and I'm going to set, I want to see this laser rangefinder information with respect to the robots from the robot's perspective. So let's add a scan message on. Okie dokes. Let's make this, I'm going to just increase the size of the dot so it can be seen slightly more clearly. Is that big enough? Let's make it a bit bigger. Yeah, that's okay. So actually I will put the axis back on, and we really need to check that this should correspond with what's in front of the robot. So let me just rotate it around a bit. Okay, and if I drive forwards, we look like, this looks like that corresponds to that wall, and we're going to drive forwards and it's coming closer to us, and I can rotate left, and that is facing the bookcase. So the laser scan is orientated correctly with respect to the robot. So this is in the direction of the robot, facing forwards, and our readings are reflecting that. So I've put this frame on our sort of grid frame as a robot's frame base link, and all of our messages, our laser scan messages, are orientated with respect to that frame. So there is currently, of course, no absolute mapping frame. Everything is just with respect to the robot's frame. That is looking good. So we've checked that forwards in we've checked that the forwards here corresponds to what's in front of the robot, is shown correctly with respect to the robot's frame. Okay, that is looking good. I think we are quite nicely set up. So next step, mapping. I'm just going to pause just for a second. Okay, well, let's start mapping. So yeah, we want to produce a map. That's the objective of this section. So for mapping, you might want to position your robot in a pose which naturally aligns with your environment. So I am going to just go back here. Let's get rid of that message. I don't think we want it anymore. Let me get the pictures back up. Okay. I like to, because there's no absolute sense of origin on the map, you can set this up however you like, but it's nice to set it up in some way that's natural. So I'm just going to position the robot some, let's get it facing one of the walls. It's just to orientate the map nicely. Okay. Ideally, I would know how to reset the odometry, but by some command, but I don't know how to do that. So I'm just going to restart my controller just to zero us into that pose as origin. So we're just going to restart the controller. Okay, that's looking promising. Okay, go back here. And we are going to start mapping. Okay, I'm just going to take us back here, just get the images back, just to explain, or maybe more carefully. Yes, I just like to have this in the center, and I like it to be orientated so that that direction towards that wall corresponds to the positive X direction on the map. So that's why I've positioned it there and orientated in that direction. Anyway, I think we are ready to do mapping. Oops, let me just, what do we want here? We've got an RViz here. Well, we can use this window, I think. Let's go here, and we are going to start the map. Okay. Now, let's bring this up. What do we want here? I think we want to see the map. Okay, and our grid frame should be map. And what else do we have to do here? This frame is base link. Failed to compute ODOM pose. Was there an error message near the beginning? Base laser dropping messages because the queue is full. To compute ODOM pose. Let's try that again. Ah, okay. Okay. Fine. We need to pay attention to this message. Okay. So SLAM-Toolbox needs a parameter file, and I have forgotten to clone this repository which has the mapper parameters file in it. So we need to go back here, src, go clone, let's go back, and let's try that again. And here we have a map. Good. Okay, get the images back. Okay, so the thing to do now is to just drive around and fill in the map. Oh yes, that's starting to fill in. Let's go down to the other end of the room. Get a bit more down there. Okay. Okay, and we're just going to do a little bit more mapping. Okay, let's just do a little bit more. See if we can get over that little carpet step there. Who knows, we may manage it. Okey-dokes. A bit further along here. Right, we've got a step coming up, so I'm not going to go any further. We're going to turn around and come back again. Let's see if we can get in here. Come round. Well, hello Thomas. See, this is where the controls all happening. We should be able to just map around in this room a little bit. We'll just do a little circle around here. So I'm still controlling this with the joystick, of course, doing the mapping. And we're going to come round. And we'll probably go back out. Let's exit this and we'll go back into the other room. There's a little bit of a wobble when we go between the carpet here and onto the floor. It could cause a problem, but in practice it doesn't seem to be too bad. So you'll see what I mean in a moment. As a wobble, yeah, there we go. Okay, I think I'm basically quite satisfied with that map. I think it's going to be good enough for our purposes. So I'm going to stop here, and we need to go to complete the mapping. So we're going to come back down here, and so we've done the mapping. Don't stop the toolbox, use another terminal. So we need to instruct the thing to the SLAM-Toolbox to save our map. Let me not stop the SLAM-Toolbox. Do I need another terminal window to do this? I probably do. Okay. Oops. Sorry, let me. What have I done here? I've actually stopped one of the transports, but that's not the end of the world. We'll just save our map here. Okay. Let's have a look and see what we've got. Yeah, that's looking very, very promising. I'll restart the image decompression from the MacBook. Okay, but we've got it saved. I'm just going to stop here. Okay, so we've got mapping. It's now time to get on to the main part, which is to demonstrate autonomous navigation. So we're going to launch Nav2 for this. Let me go back here. That's still running the SLAM-Toolbox, which we don't need anymore. Okay, and I'm now going to bring up Nav2. I want to point out something that isn't completely obvious. For some reason, if you start the nav2 and then ROS2, ROS2 doesn't bring up the map. It's best to start ROS2 first. We've already got that running, so we're fine, but I just thought I'd mention that you want to have ROS2 running first with the map topic set up, because if you don't, it never seems to receive the map topic. Okay, so we've got that. I'm just going to start that. Okay, and we go to ROS2, and what do we want? We've got a map. Actually, no, this is fine. I want to display axes on this, and I want base link. Okay, let's have a look at the images again. So I need to say, and we need to give it the initial pose estimate before anything's going to work. So kind of guessing somewhere, but we're somewhere about here, I'm guessing, and I'm going to point the arrow. It's pointing roughly in that direction. So I click down with at the origin, and I'm holding the mouse button down, and I can now point its direction, and I'm going to set it something like that. And it's now giving me the axis, so we're in the frame. Our global frame is the map, and my axis, this thing here, it's done, or its frame is the base link, which is a robot frame. So that should be moving around as we move around, and we should be good to go for. So I've got the joystick put down now, so anything that you see onwards is not the joystick. We're going to try, let's be modest first and just try and get it just to change direction. So I'm going to point it like that, left click to set the position, and then wiggle the mouse around to set the direction, and let go, and hooray, it is moving. Let me have another look at my instructions. I think I've forgotten to do some things. Optional steps. We're going to add a path so we can see what where it's planning to go, and we want to add a global cost map as well. Okay, so let's make sure we've got that going. So it's the path we want. Where is the path? Where is the path? Let's use plan path. Okay, and also you suggested the global cost map. So this is an indication of sort of preferred routes and forbidden routes due to walls. Let's get that up. And I suggested that because it's a cost map, we might want to use the color scheme cost map. It's just a little bit clearer. Okay, dokes, let's bring the images back up. Okay, and I'm going to try and shift this map slightly to the right, if I can remember how to do that. Nope, that's not correct. Zoom in again. Is it the shift key? It looks like it is the shift and the left mouse key. Okay, let's go in again. Actually, I'll just shift that around a bit. Let's go in a bit further. Yeah, that'll probably do. Okay, well, let's be more ambitious. Let's just see if we can send him around here. And you can see the map. Should I change the let's change and change the color on the map, on the path. What should we make it? Nice Is yellow good colour? Maybe, we'll find out. Okay, let's be more ambitious. Let's see if I can send it into the corridor. So I don't want to send him down the stairs, so I'll be relatively cautious, but I think that's fine, and we'll have him sent round like that and see what happens. Okay, bring some more of this up. Okay, so you can see the path. That's where he thinks he is facing, and he's off. I probably need to alter the velocity constraints on it just to slow it down a little bit. I've just left them at the defaults. It seems to be going quite slowly at this point. It seems to be a little bit cautious. It's not given up. It's probably because it's a relatively narrow entrance, and you can see here there is it's just being cautious because it's quite close. Possibly a little bit over cautious. It's one of those things that one might want to tune. No, he's decided to spin round, so that's obviously a recovery. One of the recovery algorithms. Oh, he's deciding to. Is he deciding to reverse? He's coming in like that. Okay. And he's decided to go for it. Okay, hopefully he's not going to go over the steps. Okay, he's turned round, and I think that's it. If you actually have a look at the output of this, it says goal succeeded. So this is the output of Nav2. Let's give another route. Let's come in and say hello to me. Well, hello Thomas. There he is. Okie dokes. Let us send Thomas back into the original room, and I'll send him back in this direction. Has he finished? Yes, he says he's finished. Just some parting words. It's a LiDAR thing, which is a two-dimensional sort of cross-section or view. So he can see obstacles in that direction, but things that are slightly above and slightly below are not visible within that cross-section. So I'm just going to spin round. If you looked at the television set, it's got sort of bits jutting out above and below, so I'd probably be quite cautious about sending the robot in very close to that. There are mechanisms in Nav2 for setting up sort of danger zones, but I think that's a bit out of scope for this demonstration. Well, I hope you found that interesting and enjoyable, and have fun. Thank you.